Bismillahirrahmanirrahim. I'm Mustafa and today I will be giving a presentation of a project which is unaware handwritten deduction for scan forms. So basically our project statement is very straightforward, recognizing handwritten units from different scan forms like in different applications like banking, postal codes, exam roll, and different application. So we'll be basically applying the model, not only applying them, we'll be predicting them which is a with a certain uncertainty factor and trying to improve the accuracy and adapt to a new writer as well, to a new writer writing as well. So this is our related work which has already been done in Le-net5 EMB's dataset, which is an expansion of the EMB's dataset, which is the most common used benchmark. So the data that are MNIST, which is this one, this dataset, and an expanded version of this dataset will be used for testing EMNIST. And then to apply the domain shift, we will use another dataset which is very different as it uses 16 by 16 grayscale images. And the the images are also different from the ones used in EMNIST and MNIST dataset. Like they are blurred as well, and they have thin stroke writing as well. So this is our brief overview of the data preparation, like we'll pre-process, then we apply augmentation, like clipping, mutation, and etc. And then we'll apply segmentation, like we'll segment the digit from a single image. So we will see upon that in the methodology section. So basically, this is our model Le-net5 crossing topic loss and add-on or STT optimizer are used for learning, and these are what parameters for evaluation of the model as well. So moving forward to the pipeline, this is our seven-step methodology pipeline. We first prepare the dataset, then we segment the input image, whatever input image is being, and then we will perform CNN training, calibration, which is temperature scaling for improving of the accuracy of the model, and extension mechanism to ensure that the model gives high confidence results. Then we'll personalize or fine tune on the new writer's writing as well, and then we'll evaluate the model. So this is training, as I already discussed, on MNIST dataset. Testing will be done on EMNIST digits and USPS handwritten writing of people which are real world friendly. For image processing, the initially we will convert the input image into grayscale. We can see in the image dataset that the images are uh, in grayscale as well. So then we will resize to 20 by 28 pixel and normalize them. For augmentation, like EMGs did the dataset, the digits are rotated. So we'll rotate them to the sides and remove the elastic distortion which are present inside them, and convert them to an MNIST dataset type large images for recognition. So then we will apply segmentation if the image given to us had several digits. So how will segment them? So basically, it automatically extracts individual digits. The process starts by converting the image into grayscale, then applying thresholding. Thresholding will basically isolate the digits. So then we'll remove the we will detect the contours to identify to separate the digits from the image that we have got. So then we will the digit that we have got, we will crop that, we will pad that, and give a square aspect ratio for all the digits that will be extracted, and then it will be resized as I already explained that it will be resized before evaluation. Then it will pass to the CNN for evaluation. Next is the uncertainty estimation that will estimate our model uncertainty using the technique which is temperature calibration. So for our project, we basically implemented that to calibrate our model. This is a basically post-processing step that adjusts the model's output probabilities to get better reflection of our accuracy. Essentially, it makes the model very less overconfident on different models by using the temperature parameter, which is T. perform a sweep. Then we performed a sweep to get the optimal value of the temperature, so that the probabilities of softmax are very high to get very low expected calibration error. So for this, if you can say that if on this optimal value, if the model said that it's 90% accurate, then on 90% times it is actually confident on its values. So the expected calibration error is very minimal here. So now, as we talked about the confidence values, so confidence values are basically how confident the model is on the predicted value. So basically, the softmax probability is our confidence value. So we set a threshold here of 0. 0.8. So if it is greater than 0. 0.8, it will accept the prediction. Otherwise, it will exchange it for human review, so that human can review and pass it. So basically, it will let lower selective rate in the outcome. Then we applied the few short fine tuning, and that is basically we collected one sample per digit from new image for me in this case, and from 0 to 9 I fine-tuned our dataset on these 10 digits. So basically we extracted the embeddings from the CNN for these 10 digits. We apply two methods, KNN, to check that the little digit is nearest to which digit in the embeddings. Then we tune only the last layer for lightweighting, because the real world images are different from the ones in MNIST. So we only tune the last layer, not the whole CNN, because it will disrupt their, you can say, accuracy. So output was that it increased for the user, but you will see that it had some detriment in the result as well. So now we'll discuss the results. As you can see there, here the model has been stabilized, and we'll show you the notebook as well. The the model was learning very well, and this was how it was converging. And then finally, in the last report, the loss was increased, but in the overall process, the training and the validation loss were converging very well. Finally, after this was done, we applied temperature calibration like we already discussed, at ECE, which was our main objective. It decreased by 40%, which was astounding result. So basically, this was our main objective, and we achieved it. So in this case, if you can interpret it, so the data set will be 90% accurate when the it will make predictions. So it was enhanced, like you can see here, the calibration error was very less. Only this much of time the calibration was wrong. Like it was calibrated, it was giving wrong results, and it was accurate in this 90% of times when it was saying that it was confident. So this makes our model more trustworthy, and it is very crucial in this uncertainty aware decision making scenarios. So for USPS model, the same was applied, and you can see that the ECU also decreased, but not didn't decrease very well. Why? Because of the domain shift, as we explained earlier. Because of the writing is different in that from the EC in the from the MNIST and EMNIST. So that was a bottleneck which we were to solve. Then confidence histogram also shows that there is a peak at 1.0, mean that most of the times in the EMNIST data set it was very certain for the result, like it was certain that this is the values, like it is 0 or it's 1 or whatever, because EMNIST has similar characters like MNIST, so it was confident most of the times, as opposed to the USPS where it was less certain, because the domain shift and different characters which look like each other, like 7 and 1, like 9 and 1, and so on. So basically, this is a more spread out distribution, because it is not the same distribution of digits like in Average. It is different handwriting. So it was uh, it was improved, but it was not that accurate. But you can see that EC was very low. which shows that the model has improved. Now, for precision and recall, the most of the you can see that in this the classes have been giving a smooth curve. So precision basically measures how accurate the model can, and recall measures how many of the digits it was able to find. So it was if it was to find all the digits, you can see the precision was decreasing. So before 80% of the digits were predicted, it was giving precision of you can say 80, more than 85. So it was very cordial as opposed to here. It was a more fluctuating graph. So basically, in this you can see that if we predict less than 60% of the values, the accuracy will be 90% or more. So even at the recall of 80% was very high, it was around 80% except of only class 0, which was 0 digit because of the irregularities, or you can see the handwriting change or domain shift as well. So in the USPS, this is a bottleneck. Then the selective coverage, selective coverage shows that the model has learned in this one, which is the EMNIS data set, that it has learned specific weaknesses from the data that it identifies selling one. So this is basically an overfitting on training because in training there are several ones, sevens, and seven ones. So it was overfitting on that. So the error rate was high on one coverage because of this issue. It had to predict 7 as 1. It was forced to do that. If it didn't did that, so it could have better so we can't consolidate it equally. So we need more class specific. So we can improve that by giving class specific confidence thresholds as well. So then we can see that in which class the confidence threshold is higher or more errors are being made. As opposed in the USPS, though since the model was domain shifted and it has a basically the classes in this case the classes were affected equally. So basically it doesn't achieve a high error rate, but its error rate was very high as compared to the EMG's dataset. So, uh, but it has generalized well as it is a domain shifted and more real world handwriting as compared to EMNIST and MNIST dataset. So basically, in short, EMNIST basically reveals model specific blind spot which are 7 and 1s and this mixing between the values, while USPS basically gives a new challenging style and generalizes more. So you can see here that the error rate is being very high given the coverage, and even at lower interval, lower coverages, the point rate it is increasing linearly as opposed to here. It was very low at zero point 0.6 and below coverages because of the main shift again. So this is the confusion matrix that you can see here. The 7 and 1s are confused with each other, and 8 and I think 9 and I think 8 are confused. And these are the incorrect values which are protected for different classes. Same in the USPS, different results, but similar. These common are repeated like 7 and 1s, 9 and 8s, 9 and 1s, and these are the major errors like here you can see. So after repetitions of the training, few short training was reduced, but still there were irregularities, and that can be improved by, I think, by increasing the number of samples for few short training. I use only 10, but it can be improved. So basically, in a sense, the accuracy improved in terms of expected equation error, which was reduced significantly. However, in few short training, USPS didn't give accurate more improved result because of less number of samples. So I will show you the demo quickly, lack of time. Here you can see that in this part we will perform the demo. So here you can see that we are able to I will be doing demo. So we choose the files, and the file I am choosing here. Basically, this code will be just taking an input, pre-processing it, and segmenting it. So for that purpose, we'll choose this image, which is my handwriting to be exact. So you can see here that it significantly separates digits, gives prediction with full confidence on each head. That's impressive, as I said. So this is a prediction, as you can see here. That's all. Thank you.